Okay, so I'll be giving a presentation on our view of the IoT market and technology trends. So for those of you who haven't met me, I'm Mike Demler. I'm the senior analyst with the Linley Group. I'm also senior editor for Microprocessor Report. My areas of coverage include, of course, IoT and wearables that we'll be talking about here, processor IP, and all things related to self-driving cars and automotive technology. As far as my background, I spent more than 20 years in the semiconductor industry, everywhere from the test floor to the clean room and in between. I could say more than 30 years, but I think 20 years covers that, and we can probably just leave it at that. Besides Microprocessor Report, we publish annual guides to technologies in different areas like IoT and wearables, as well as the other areas that I said that I covered. If you want to see some samples of that, we have them on the table across the hall. That's where we get an opportunity to go in more depth than we can in our weekly articles and cover a broader perspective of the industry. So take an opportunity to look at those. If you're interested in more information or potentially want to purchase a copy, ask for Madeline at the reception desk. Okay, so for our view of the IoT market and the technology trends that are driving it, I'll start with a top-down view. And I'm sure we've all heard, read lots of different reports that estimate billions and billions of devices that will be connected to the internet. But what I very rarely, if ever, see is an actual calculation of where those devices go. If there's 10 billion, 20 billion, 50 billion, how are they connected? And in what particular segment of the market will they be used? So we try to size the market, I think, in a more logical way by taking a top-down view. There are things that you can actually count in the various segments and then try and estimate what the penetration will be. So I'll go into that in the first part of my presentation. Then I'll talk about some of the technology trends that we see, some of the new technologies that are being developed that are helping to drive future growth in the IoT. And in the last section, I'll give an update on our 5-year forecast. Okay, so just to start out by just doing a level set, this is the one graphic that you may have seen before we used last year. Our view of the IoT is that there are many, many client devices, but most of those will be connected to the internet, if at all, through a gateway. And one of the things that I think causes confusion looking at a world of connected devices is not all of them will actually connect to the internet. And I'll talk about that a little bit more later. But for the most part, we expect the connectivity to be wireless, going through a gateway that could be anything from a relatively simple sensor hub to a much more powerful computer that actually does edge computing. And so most gateways at the low end, you may see some ARM processors for doing sensor hub functions, but predominant architecture that you see is actually an Intel processor to do the gateway functions. And the same thing applies, of course, in the cloud. Our focus is on the client devices where you have unique architectures that are specifically tuned to supporting IoT applications. Okay, so what we do, taking that top-down view, we divide the IoT market for client devices into these two segments, industrial and consumer. Overall, the IoT is a very fragmented market, and there's lots of different segments to it. But we think this provides us a pretty good division for then drilling down more into the different application spaces. So under industrial, we'll have smart buildings, cities, smart energy, the power grid, smart pharmacy, agriculture. We put in industrial category, as well as smart factories, which would be typically what you might think of as industrial IoT. We also include health and medicine, retail, and shipping. Now, There can be some crossover between that and consumer. In smart homes, that would be an opportunity to have many connected devices, connected appliances. Connected vehicles we put in the consumer category because most of those are purchased by consumers. Wearables, although some of them may have a medical application, those would also tend to be purchased by consumers. So what I'll do next is then look at what we see as the largest categories, at least as far as for the potential market or the total available market for IoT client devices. So, as you'll see, by far the largest potential market is the connected home. We've heard a lot about Nest thermostats, smart thermostats, lots of other devices that could be connected, from smart door locks to electrical outlets, alarm systems, sensors that detect if you have a water leak. Again, a lot of those devices, I mean, if you have smart lights, you really need to connect them all to the internet. Some of them will be, some of them won't. For our purpose of trying to size this market, we exclude devices that we would consider to be sort of conventional, if there is such a thing, connected devices, such as smart TVs, or devices that are just media download devices, set-top boxes, for example. And PC and smartphones are excluded from our market estimate, although we have seen others that include those. And so to size this market, we can count how many houses there are in the world, how many residences, and how many have broadband internet access. Now, even though the sensors may not have demands for very high connection speeds, typically to have Wi-Fi, which we think is the most prevalent mode of connectivity that you'll see for smart homes, you would tend to have the need to have a residential broadband connection. So today there's about 800 million worldwide. That's projected to grow to 1 billion in 2022. But when we look, even in the United States, as advanced as we are, and sometimes getting a skewed view of the world in Silicon Valley, 39% of rural America doesn't have a broadband connection, and that really comprises about 10% of the whole population. But as I'll show later on in the presentation, that really calls out for the need for other wireless connection methods, because you drive through a rural area, even cell phone wireless connections are spotty. So, because we've seen the smart thermostats, we expect that to be fairly high adoption. That has a pretty direct impact on people's utility bills. So that's been the most popular category, at least to start out with. But when we actually look at the number of devices, you'll see many more in applications that need, for example, multiple sensors. In alarm systems, you have one attached to your windows and doors. In lighting, you have multiple lights throughout your house. So those markets eventually, as far as the actual number of processors, will be much larger, 1.8 billion for security alarm systems and 4.5 billion for lighting. We see a variety of wireless connectivity protocols. Bluetooth mesh is a new one that I'll be talking about. There's proprietary Wi-Fi as well as Zigbee and 802.15.4 variants. This is the largest market. The next largest, some similar applications in smart buildings for smart lighting, for heating and air conditioning control, but there are many other potential applications there as well. Commercial buildings, businesses need access control. It could be an airport, a museum, a shopping center with Bluetooth beacons to help guide people through the facility. Alarms, maintenance, you can have sensors to keep track of the usage of the restrooms to alert you when the supplies need to be replenished. So to size this market, we count buildings. And so there are about 30 million commercial buildings worldwide. And we can take an estimate based on the average square footage. And so this market we project to be about 2.5 billion client devices as far as the total size of that market. And most of these are going to be very low-end sensors using MCUs with built-in radios. Some higher-end devices for security, for video cameras, may use higher performance processors. And some of the same connectivity modes are used here as you would expect to see in a smart home. Next largest market potentially for IoT is connected vehicles. We hear a lot now about people aggressively forecasting the rollout of self-driving cars, and those will require connectivity. This is a topic we'll discuss a little bit more later on in the panel this afternoon. But back in the 1990s, the U.S. Department of Transportation was starting to try and define what they called an intelligent transportation system, and they set aside the 5.9 gigahertz band for ITS to handle vehicle-to-vehicle and vehicle-to-infrastructure communications. Defined this method called DSRC, or Digital Short-Range Communications. It's since become an IEEE standard, and that's used in the ETSI, the European ITS, as well as in Japan. And the intent here is to have very small, very short-range messages for communications between vehicles and, say, the traffic lights to alert a driver that's being inattentive to a red light or potential of a collision. This does require roadside units, and that's been one of the issues we'll be talking about later on this afternoon. So now that it's taken so long to roll this technology out, in the meantime, of course, we've had advances in cellular technology, 3G, 4G, and now we have early deployments of 5G. And so the companies in that segment also see this as an opportunity and have potentially some technical advantages for even lower latency than in DSRC. And so it's contentious at this point. We think in the long run, this will go towards smart cities and smart transportation systems using 5G. To size the market, if you look at all the vehicles in the world today, there's about 1 billion passenger vehicles in the world. Every year, there's 90 to 100 million that are sold. So this is potentially a fairly large market, but right now the penetration of connected vehicles is very low. Last year, 12.5 million were sold. But if we do have more advanced autonomous vehicles rolling out in the next few years, they'll require even more connectivity, and for lots of different reasons. One is for the mapping and localization. You need much more precise maps than your average GPS will give you to have the car be able to drive itself. That could be through the cloud, through crowdsourcing, similar to what you do with Waze today. These vehicles will need to communicate to each other the way that we communicate today, hopefully in a more friendly way. And so there's lots of reasons that you might need wireless connectivity in a vehicle. So this is another large potential market. Next one I want to talk about is agriculture, smart farms. I was a little surprised when I did this research to find that there are 3 billion cattle, goats, sheep, pigs worldwide. They don't all need to be tracked. Some of them graze on fenced-in areas, but in other places, cattle will graze openly, and there's a process that the ranchers go through to round them all up, and that you can result in loss of an animal or theft. And so there's an obvious ROI there where a sensor could cost just a few dollars to keep track of your prized steer. There's also opportunities in crop soil monitoring, irrigation control. But even there, maybe not as large as some people may think, because in the United States, only 10% of farmers actually use irrigation. It still would help to monitor the conditions, but they rely on Mother Nature, so they don't really have control over irrigation. In sizing this market, there are 50 million corporate farmers worldwide. There's actually about 10 times that many, which is astounding, 500 million family farms, small farms. Not to say that those aren't potentially a market also to have some of these sensors, but what we focus on most is the commercial side, where they can realize the cost savings more easily. And so we estimate this to be a total market of potentially 1 billion devices. Because the sensors are in the field, you can't use Wi-Fi. You could use Zigbee mesh, and there's been some demonstrations of that. You can build mesh networks that are connected together to cover fairly large areas. But we see this as a big potential for the low-power, wide area network technologies that are rolling out, and I'll talk more about that a little bit later in the presentation. These devices, again, for the most part, will be fairly low-cost devices, MCUs with radios built in, but they will need some sort of localization method, GPS or alternative methods to know where your asset or your animal is. So smart factories for the industrial IoT. Obviously, there's lots of advances in machinery. Not all the factories that we look at are heavily mechanized, but you have opportunities there to control, monitor machinery and processes, to track your material and your finished goods. This is a market of potentially, there's about 10 million factories worldwide. We estimate about 150 million, so it's a smaller market overall, but has a lot of value because you're talking about manufacturing processes that are able to absorb costs higher than, say, a consumer application. In a lot of cases, these sensors are going to be built in the machine, and they'll be more likely to use wired connections than wireless in a lot of cases, and using some of these older serial links like RS-232 and 485. For wireless technology, we expect to see Zigbee in the smart factories, along with the wired Ethernet connections. Now, this is one area where you can have lots of sensors and actuators, control mechanisms, but it's unlikely that you'll be connecting those to a public internet. For data storage, it'll probably be on a private cloud, not so much on the internet. Last year, fitness bands again were by far the largest application for wearable technology. Also, watches 3 to 1. Those devices just simply connect with Bluetooth, so very inexpensive chips go in these devices. Higher-end wearables may have some tracking capability, so you may have some functions, especially for sports. And then there's a few standalone with built-in cellular connectivity. You've seen examples of that for Samsung, for example. And then for child trackers, it's a popular application in China, and all you need there is a fairly inexpensive cellular radio with GPS to keep track of your child. So, to be optimistic, you could say, well, there's the market, about 2 billion smartphone users worldwide, and that continues to grow. We only expect about 10% adoption for people using smartwatches that, for the most part, will be connected to their phones. There are other wearable categories, although the media seem to have just discovered it in the last few days. Google Glass never went away. Google was working on Glass for work for the last few years. The other day they released this Enterprise Edition, and they have industrial partners that are using this for people that are working on assembly processes. It's good for first responders, for emergencies, so that you could have, say, somebody in the field or in a battle situation that wouldn't have to turn away or go connect to a computer to look up how to treat a patient or their records. So this is another market of potentially 50 million. Then finally, there's a smaller segment, but more expensive devices for medical, for implants. We see pacemakers and things like insulin pumps that might have wireless connectivity now. So when we add it all up, we summarize our top-down view of the market for IoT client devices. By far, the largest potential market is smart homes on the order of 7 billion devices. Keep in mind, this is measured in total units. It's not in revenue. You can look at our IoT guide for more detail on the revenue side of this. And the next largest segment is smart buildings with about 2.5 billion. Connected vehicles and smart farms, both potentially on the order of 1 billion devices, and then smaller segments below that. So if we look at, where are we today with all these projections that we've had for billions of devices, we see about 1.6 billion connected devices. Industrial IoT, the segments that I talked about as industrial, they continue to comprise the large majority. There's been a lot of adoption of smart meters, and that's been the largest application category. Consumer and wearables has been roughly split 22-21% of the market for those categories. We expect the industrial category to continue to ramp up, and then we're a year or so away from seeing what we think is going to be much higher growth for consumer devices. Okay, so we expect to see future growth, and so I'd like to talk about some of the technology that we think will help drive that. I mentioned some of the need for low-power wide-area networks. I'll talk more about that. I'll talk about the new Bluetooth mesh technology. And then you'll be hearing a lot from IP vendors here today and tomorrow. That's one of the keys to enabling devices that are more highly integrated. I'll talk about some examples of that. And then processor manufacturers that are building SoC purpose-built devices. We'll go over some examples there. So for low-power wide-area networks, this picture I took from the LoRa Alliance. They're one of the contenders for offering this kind of a technology. You just look at this picture. It's similar to the one that I showed at the beginning. Rather than having, the gateway here could be a LoRa gateway. It could be something for Sigfox as well. You can connect, potentially, the advantage here, you can connect from much further distance away. So you're not using a local area network. You're using something that could connect possibly a mile or more away. So that really opens up the capability of connecting a large number of devices without having to deal with all the problems of a Wi-Fi LAN. The sensor data gets aggregated, sent up to the cloud, and then the customers of this particular, whatever service, then can run it either on their own IT network or in a cloud platform. So the advantage here is that whether you're using one of these LoRa Sigfox technologies or an LTE, you can connect to devices that would be difficult to connect to otherwise, whether they're in the field, they're moving, they could even be underground, say with a drilling rig. And you only require the high bandwidth for the backhaul, so you can have a fairly low data link for these. The leading technologies are LoRa Sigfox, the LTE variants, the LTE Category M, and NB-IoT, and then 5G is coming. And there's others I won't spend any time talking about. There's a GSM variant, EC is Extended Coverage GSM. There's some other startups, Ingenue and Wireless, that are also trying to deploy these kinds of networks for the IoT. So this table summarizes what we see as the leading contenders for low-power wide-area networks. LoRa technology was developed by a chip company that I think is here in Silicon Valley, Semtech. They've been rolling out worldwide. They got 30 operators that have adopted this. Now, the key here is LoRa is not a network operator themselves. They've developed the technology. They license it to these companies. In some cases, there's cellular companies like Orange in Europe where they combine that with their LTE network to conserve their bandwidth and address some of these lower data rate requirements. LoRa only goes up to 50 kilobits per second maximum. In the United States, you have companies like Comcast, Xfinity. They're also an internet service provider, but rather than use up their wired high-speed broadband connections, they can roll out LoRa and combine that with their packages like they have today for smart home, for home security, and things of that nature. Sigfox is a French company, and we have a representative from Sigfox on our panel this afternoon, so I'll leave him to talk about this in detail. Like LoRa, it uses unlicensed spectrum, only uses 200 kilohertz of bandwidth. In this case, the data rates are even lower. You either have 100 or 600 bits per second. And the idea here is that you're connected to sensors that only need to communicate uploading a few messages per day, up to a maximum of 140, and relatively infrequent downlinks for any updates that need to go out to the client device. You have more chip companies that have built devices for this market, for Sigfox, because it wasn't a proprietary technology. And they operate their own networks, and we'll hear more about that, also in North America as well as other parts of the world. 3GPP, the industry organization that develops the LTE standards, has also rolled out various specifications for how to address the needs of many devices that have very low data rate requirements. LTE Cat M1 is the one that we're seeing roll out here first. Uses the standard Cellular spectrum, which is an advantage, they only use 1.4 megahertz of the bandwidth. For wireless carriers like Verizon and AT&T, they can roll this out basically through a software upgrade on their existing base stations. And so that's what we're seeing, but we're seeing the first deployments just this year from AT&T and Verizon in the United States. The chip vendors that are addressing this market are the same ones for the most part that would have addressed other cellular applications in mobile devices or in the M2M market. The next technology coming then is the LTE category NB1 and NB2. This further reduces the bandwidth as well as the data rate. Conserves spectrum to be able to address a high density of sensor nodes. We're just expecting to see the first deployment in the United States this year. T-Mobile says that rather than roll out M1, they'll roll out NB1. All the Chinese cellular operators have adopted this. And so that produces a market for companies like MediaTek that are well connected in the Chinese mobile and cellular market. And then in the future, we'll have 5G LTE, and then some of the advantages here, it can combine both licensed and unlicensed spectrum. We expect to see more enhancements specifically for IoT, better use of spectrum, to be able to address the need to connect many more devices than you would today with just smartphones and such. And we don't expect the first deployments as far as you hear a lot about the hype of the free trials. The first commercial deployments we expect to be still about 2 years away. So you may have seen some of the news about the new Bluetooth mesh capability. This is something that various companies in the Bluetooth SIG have been working on to try and position Bluetooth as a competitive technology to things like Zigbee and Thread and other mesh technologies. And it could address smart buildings, factories, and homes. We were all familiar with Bluetooth as a point-to-point technology. This changes things somewhat to a mesh topology. I think one of the issues potentially is that 2.4 gigahertz band is pretty crowded, and you can have problems with interference. According to their white papers and such, they say that because the mesh technology and that topology and having this broadcast mechanism with multiple nodes, that any one point of failure doesn't interrupt the communications, but that's part of their design. It combines sensor nodes with relay nodes. There's a multicast, multipath architecture. And one of the nice things is they built in security features, so all the communications are scrambled, uses encryption, and they built in procedures for addressing potential for hacking attacks. So this can potentially connect lots of devices. You could have a light switch that's just Bluetooth connected that can control many different devices throughout your home. But again, the question is, are these really going to be IoT devices? It'll be easy to connect devices wirelessly in your home or your building, but that doesn't necessarily mean that there's a need for those devices to be accessible outside. Okay, one of the key technologies to enable these processors is the availability of the new licensable IP cores they're more well tuned for these low power applications. And I'm just going to give you a couple of examples. One of the keys, of course, is to include security, and that had been lacking in the first generation design. ARM will be presenting here at the conference. I'm not stealing their thunder because I don't think they're talking about this particular product line. But I wanted to just highlight, this is a really good example with the Cortex M23 and the M33. ARM added the trust zone technology to MCUs. This is something that was previously only available in Cortex-A, but now you have so many microcontrollers, you need this capability to isolate trusted versus untrusted applications. It provides upgrades. The M23 is sort of a Cortex M0 class device, and the M33 is similar to M3, M4 in its capabilities. What's good about this also is ARM didn't just stop with the CPU. They have the CoreLink product line, the SIE 200, that allows you now throughout your SoC to apply trust zone to the peripherals, to your flash memory, and such. So you have that security built in throughout the entire SoC. They acquired some security IP, so they have the crypto cell line, so that enables you to include encryption capability on your chip. And then I think for the first time, they assembled all of this into an example subsystem called CoreLink SSE 200, and that's the block diagram that I show there. And you pretty much have all the blocks that you need to build a secure wireless IoT processor, the CPU, the system interconnect. ARM also now has some radio IP, that's the Cordio radio, and your trust zone capability. So we haven't seen any products yet using these new cores, but we expect this will help to accelerate, and especially get people to market more quickly by having fully tested and verified subsystems. Synopsis is also one of our sponsors. We'll be giving 2 talks here at the conference, and I think they're also covering some other areas. I wanted to highlight this one. The Arc SEM line added security to Arc EM cores. Also has similar, in some respects, to Trust Zone, but I think with more features. The trusted execution environments that you can have with their Secure Shield technology, multiple privilege levels. You have the ability to incorporate all of the encryption and security IP, secure debugs. And what I think is interesting about this architecture is how it was built to be very tamper resistant and to thwart hacking attempts. The entire instruction pipeline is designed to be tampering resistant with built-in encryption and address scrambling. And then a little clever design feature that they incorporated countermeasures against side channel attacks. A hacker could potentially look at the power supply line or potentially even pick up EMI radiation from a device to try and pick up an encryption key or some secure password. And what Synopsis did with this design is they randomized the timing, and they will insert no ops. They'll adjust the timing so that there's no pattern to it that could be detected to allow somebody to break into your device. And then they also have their encryption IP, and I think they also, as well as ARM, they do license some radio IP as well. So you can go to these vendors and pretty much get everything you need to build a wireless IoT chip. I won't be going into detail because these are some of our other sponsors that we'll be presenting, but you'll hear more about this, these companies. Andes will be talking about some new cores that are configurable and designed for IoT. That's in the next session following my presentation. Cadence is in session 3 tomorrow, talking about some new DSPs geared towards IoT. SIVA is in the next session, talking about the X1 processor cores. Those are DSPs for wireless connectivity and for NB IoT. And then we also have talks tomorrow afternoon on security IP from Inside Secure, Rambus, and Synopsis. That's in session 4 tomorrow. Arteris, we talked about system interconnect, the importance of being able to have that security throughout your entire SoC. Arteris will be talking about their network on a chip technology in the next session. Okay, so moving up from IP to SoCs now that are purpose-built for IoT, we saw in a lot of cases, just to enable connectivity in an early first-generation IoT device, you could take an MCU and you could take a radio chip. You can combine those, and you can get up and running on any of the wireless protocols that I mentioned. Smart watches, they repurposed smartphone chips. Either turn off part of the chip or run them at a lower clock rate to try and conserve the power with a smaller battery in a wearable. But what we're seeing now in second generation designs is they're more highly integrated and more highly optimized for IoT. Just wanted to cite a couple of examples. Recently, the Qualcomm MDM9206, that's a small application processor. It has a Cortex-A7 CPU. But it has the built-in digital baseband modem for the new Cat M1 and Cat NB1 IoT technologies. MediaTek with the MT2625, it's an MCU. It's got a Cortex M4 core. This is the first that we've seen where they actually build the radio, and that was one of the promises of these narrowband LTE technologies is that they would, for the first time, allow you to build the entire radio on a chip, similar to what companies have been able to do for a while with something like Bluetooth or Zigbee. So that's the MT2625 for IoT clients. And we're seeing highly integrated and optimized designs for wearables as well. And Samsung's Exynos 7270 is an example where it has dual application processors. These are lower power Cortex A53s. It has a GPU, so it can drive probably more higher resolution graphics than you could actually see on a smart watch. And it has that LTE modem that's built into it. For a lot more detail on this, I'd point you to our guide to processors for IoT and wearables, and Linley will be presenting tomorrow afternoon, so be sure to come for that. He'll give a fairly detailed review of how we do segmentation. I went over the market segmentation. He'll go over some of the technology segmentation of the processor market for IoT. Okay, so next, go over our update to our 5-year IoT forecast. So you've seen us present this, I think, in the last year or so. In the past, we had forecast that for the markets that I talked about, that they would hit their peak run rates, and we expected that to happen in 2019. And what we've seen is that that's happening even more slowly than we had, I think, conservatively projected. Although we expect shipments will pass 1 billion for the year in 2019, I think the market will still be at an accelerated growth pace then, and we won't see the peak until 2 years later in 2021. And some of the issues we think that have been holding it back have been cost, because devices haven't been as highly integrated as they could be. Lack of standards is still an issue. Limited infrastructure. The markets I showed are huge potential markets, but lack of connectivity, say, in the field, would make it more difficult for companies to implement, whether it's smart agriculture or shipping and such. And so that's something we'll talk about a lot more later. But nevertheless, industrial IoT has continued on that steady ramp. We expect consumers will follow that traditional S-curve that we see in consumer markets, and then finally, it will, consumer segment will surpass industrial in 2019. We'll go very quickly from 1 billion devices shipped in 2019 to more than doubling that in 2023 to 2.3 billion. So we expect IoT will shift towards consumer as costs drop, and in consumer applications we saw with the example of the smart home. There's many more potential applications there, and there's nearly a billion residences worldwide that you could access. But to really increase adoption in that market, we need more refinement of devices. We think that something like Alexa started out, I think I talked about this last year, I called it sort of a Trojan horse. Ease of use for consumer is key. As tech savvy as we are here in Silicon Valley, I know a lot of us, I do, still have difficulty making all your smart home devices play right together. We'll talk more about voice UI. I think that's a key, not having to deal with all the commands or interfaces for different devices, but just have that voice interface that could take care of all the devices in your home, like we've seen in the past on Star Trek. Just talk to the computer and have it take care of things. But we have a long ways to go. I mean, I think natural language interface is a misnomer. There's nothing natural about talking to Alexa, if any of you have had those devices in your homes, or Google Home for that matter. I recently added another Chromecast to a TV in our bedroom, and so I called it Bedroom. It's part of the installation process. You give it a name, and it's pretty cool that Google could actually recognize what name I give it. So I didn't think Bedroom was all that clever. It should be pretty straightforward. Went over to my Google Home, and I said, okay, Google, play my jazz in Bedroom. And it wouldn't work. I'm looking at what was wrong with my setup. I'm looking at the Google Home. I'm looking at my... Meanwhile, my wife goes online, and she looks up I said, oh, you need to say 2. Play jazz 2-bedroom. It's not the way I would naturally say it, but okay. And that works. Okay, great. So we've got a long ways to go. Right now, these devices are teaching us how to speak their language instead of the other way around. And that drives me crazy. And Alexa actually reprimanded me for insulting her the other day. So anyway. But anyway, what we do see, Alexa was, in Amazon and Echo, there was a huge hit at CES. They got all these manufacturers going to build the device, that interface in, including cars. And so I guess, be careful. Your kids will be in the backseat shopping on Amazon from your car. But that's how pervasive we expect those interfaces to be. And so we'll talk about that a lot tomorrow morning. So again, what we're looking at, maybe a little bit more than 5 years out, but 2023, at that point, consumer will make up about 72% of the IoT market, with connected home being 39% of them, being the largest category, along with wearables and smart appliances. Together, that'll add up to 72% of the market we see in 5 years. Industrial, for the applications we see here, smart meters, smart buildings, and all the other industrial categories will be about 28% of the market, but because those devices are more expensive, that'll still hold about 33 or a third of the revenue in the next 5 years. So we look at the installed base for IoT clients. We talked about 1.6 billion devices we expect at the end of this year. We expect this to grow to somewhat over 10 billion in 5 years. So 10.4 billion in 2023. This will rise to an average of 13 devices per house, which is sort of one of the figure of merits people use. When we look at those markets and consider how we size them, we think that that provides a more rational bound on the size of the market. We know how many factories there are. We know how many farms there are. From that, if we can increase penetration or develop new applications, it can grow even further. And you may have more devices per hotel than we might have projected right now. But at least we know that that's the size of the market that we're starting with as the foundation. And we look at a 10-year life cycle for IoT devices. For wearables, we expect that consumers will probably want to change their Fitbits or their smartwatches more often, maybe every 2 to 3 years. In conclusion, we do see the IoT market does continue to grow. Growth in the consumer segment has been slower than some may have projected. We see industrial still being the largest segment for the next 2 years. In 2019, we solved some of these usage issues and reliability issues. We expect consumer will finally overtake the industrial segment. But again, it depends on seamless connectivity and reliability. And if any of you users are working on these devices, I plead with you to think about how you can make them easier to use, and then you'll see consumers adopt them much more readily. The IP vendors helping to drive new applications with processor cores that you can use to build customized and optimized IoT processors, whether it's the CPU, a DSP, or other components of a system on a chip. And I think that the deployment, whether it's LTE in some of the lower power wide area network technologies or the unlicensed technologies that are trying to also compete at lower cost, will help to drive proliferation of multiple sensor nodes in lots of different applications. The Cat M1, and it does have the advantage that overnight Verizon or AT&T can say that they have pretty much coverage all throughout the United States. So we'll see if that drives growth in the market. T-Mobile, they've been very aggressive in general of trying to take business away from their competitors. And so they're jumping a step ahead with NB-IoT. And then LoRa and Sigfox, these are already very low-cost devices, and we'll see some more examples of that this afternoon.